Unit 33. Alternating current AC. Tan. On the radio in my house, there are two places to plug into the machine. A place is DC 6 volt and the other is AC 220 volt. I don't understand what these symbols mean. The direction of the induced current. Experiment. Connect two LED bulbs to two ends of a coil, a red bulb and a yellow bulb, in parallel and opposite direction as shown in figure 33.1. Perform the experiment and indicate which bulb is bright in two cases. The magnet is plugged into the coil. The magnet is plugged from the coil. Hence, tell what the differences are in the direction of the induced current in the two cases above. Conclusion. When the number of magnetic field lines through the cross-sectional area S in the coil increases, the induced current in the coil has the direction opposite to the direction of the induced current when the number of magnetic field lines passing through that cross-sectional area decreases. If the magnet is moved in and pulled down of a closed coil continually, the alternating electric current appears in the coil. An electric current periodically reverses its direction of movement is called an AC. An AC, alternating current. Page 91. How to create an alternating current. Let the magnet rotate in the closed coil. Analyze to see how the number of magnetic field lines passing through the cross-sectional area S of the coil changes when we let the magnet rotate around the vertical axle of the coil. Hence, infer how the direction of the induced current appearing in coil changes. when the magnet rotates. Perform an experiment to check your guess. Let the coil rotate in the magnetic field. Figure 33.3 shows a closed coil which can rotate around a vertical axle in the magnetic field of a magnet. Analyze to see how the number of magnetic field lines passing through the cross-sectional area S of the coil changes when the coil rotates. Hence, infer your comments about the direction of the induced current appearing in the coil. Conclusion. In the closed coil, the induced current appears when letting the magnet rotate in front of the coil or letting the coil rotate in the magnetic field. Page 92. Figure 33.4 shows a closed coil which can rotate in the magnetic field of a magnet. Two different LED bulbs are connected in parallel but in opposite directions, with two ends of a coil at the same place. When the coil rotates, two bulbs are bright, creating two halves of opposite light rings. Explain why each bulb is only bright on the half of the ring. The induced current in the closed coil changes the direction when the number of magnetic field lines passing through the cross-sectional area S of the coil is increasing but tends to decrease, or vice versa. When letting the closed coil rotate in the magnetic field of a magnet, or letting the magnet rotate before the coil, the alternating induced current appears in the coil. You may not know when the closed coil rotates in the magnetic field, the induced current in the coil changes its direction regularly with every two rotations. The number of rotations per second of the coil is called the frequency of the alternating current, measured in hertz. Okay. In our country, the electric current in the national electric network, which is put to the socket in the house, is the alternating current with the frequency of 50 Hz twice every rotation. On electrical appliances, they are usually the mark AC 200 volt, which stands for alternating current, meaning CQ, or DC 6 volt, with DC standing for direct current, meaning không đổi một chiều. Formulas about DC can be applied to some common appliances using the alternating current.